Hello, this is a video explaining the homework problem on page 18, problem number 5. Watching this video will help you make corrections to your assignment and make sure that you have all the correct answers when you turn it in. This is problem number 5. For each of the following functions, indicate whether it is an example of direct variation, inverse variation, or neither. For those functions that are examples of direct or inverse, identify the constant of proportionality and write a sentence describing the relationship in the language of direct and inverse variation or proportionality. For this assignment, I've got this as kind of a fill-in-the-blank looking thing. For the sentence, you would be expected to come up with a sentence that looks like this on your own without the fill-in-the-blank model. Part A says the surface area of a cube which with edge length E is given by A equals 6E squared, where A is the surface area and E is the length of an edge. So the variable area is, in this case, we've got, it fits the pattern where there's a variable on this side and a variable on this side, and they're both on the top of the fraction. But we've got an exponent, a little squared there. So this is directly proportional. The variable area is directly proportional to the edge length squared. To edge squared. With a constant of proportionality of whatever the number is here in front of the variable. In this case, it's a simple one, like 6. So we'll just write in the constant proportionality, 6. So that one was pretty straightforward. The next one, when a basketball player attempts a shot from midcourt, the height of the ball h is a function of time in flight t. Those variables might be related by a rule like, this should be very familiar, we did a lot of these, negative 16t squared. So far, that's a number, a coefficient, in front of a variable squared, which seems to fit the pattern. But this part right here makes it neither. It is not direct, nor is it inverse, because of those extra terms there, the variable t and the constant 7. So this one is neither. Part C. The volume of a sphere is related to the radius r of the sphere by v, volume, equals 4/3 pi times the radius cubed. So in this case, the variable volume. And is it inverse or direct? Well, there is a fraction right there, I admit. But by the laws of multiplying fractions, that r cubed is in the numerator of this. So v is directly proportionate to r, but its v is directly proportionate to r cubed. So this is, volume is directly proportional to radius cubed, with a constant of proportionality of, this one's a little complicated too, the entire constant of proportionality is 4/3 pi. Pi looks like a variable, but we know that it's a constant that we just don't write out every time. It's 3.14159, etc., etc. But we just leave it as 4/3 pi, so that's the constant, 4/3 pi. So the variable volume is directly proportional to radius cubed with a constant of proportionality, 4/3 pi. Here's another one that's got a twist to it. The diameter d of a large tree is related to the circumference c of that tree by d equals c over pi. And this one's complicated because the c over pi can be rewritten as 1 over pi times c, the circumference. And that works by the laws of multiplying fractions. So writing this in, the variable diameter is it directly or inversely? The ones with a fraction usually look like they're inversely, but this is just the formula for circumference rewritten so that it is d in terms of c. Notice that the d and the c are both in the numerator of the fraction, so that makes it directly proportionate. So the variable diameter is directly proportional to the circumference with a constant of proportionality of, just like we saw down here, the constant of proportionality is 1 over pi. Another nice complicated one, the radius r of a circle is related to the area A of that circle by r equals the square root of A divided by the square root of pi. Now we are used to seeing the area of a circle equal pi times r squared, and what they've done is rewritten this so that it's r equals. So we've got r squared equals a over pi, and taking the square root of both sides of that leaves us just with r equals the square root of a over pi, because of course the square root of r squared is just r, and by the laws of exponents we know that we can divide this up into square root of a over the square root of pi, which could also be rewritten as 1 over the square root of pi times the square root of a. Now the square root of a is just an exponent, so this fits with our power model of direct variation. The square root of a is the same as saying a to the 1/2, or a to the 0.5 if you prefer. So to write this into a sentence, the variable radius is directly proportional to the variable square root, I'm abbreviating there, square root of area. And yep, that's a little bit complicated, but what can you do? The variable radius is directly proportional to the square root of area with a constant of proportionality 1 over the square root of pi. Again, pi is a constant, not a variable in this case. Last one. The balance B of a savings account after n years with an initial investment of $500 earning 6% annual interest is given by B equals 500 times 1.06 raised to the n power. Raising to a power seems like one of our power models, and this looks a little bit like direct variation, but the fact that the variable is in the exponent's place means that this is neither direct nor inverse. So it's neither. And we're done with that homework problem. Now, make sure that you have made all the corrections. Feel free to go back, rewind this video, pause it, make sure that you understand each of the problems, and turn in the assignment. If you are done early, feel free to get a start on either the Exceeds or Honors Challenge problems that were due today, if you didn't do them, or get a start on the rest of the assignment for today. So we're done.